Hello and welcome everyone. I just want to give the solution of this problem known as binary coefficient. Very straightforward, and the solution is straightforward too. What you need is simply draw an example and look at the pattern. Once you figure out the pattern, you just implement that in the code. This is exactly how you're going to solve this problem. For example, now here, what we're going to simply have to do, you're given a code. You're given a code which says that it is not and what you will try to do is simply try to implement it and try to draw some examples. And this code is not exactly trying to find out the binomial coefficients, rather a slightly different version of it. I'll go and I'll show you in the examples how it actually looks like. So now you see, finally, what you have to do is you have to, for t queries, you will be given n and k, and for each and every n and k number, you have to find out what is the nth row and kth columns coefficient number, or the value, the array value number. Now, what is the array? I tried to draw the examples, and it turned out to be this one. You see, this is the result of n. If you take n from 0, 1, 2, 3, 4, 5, n up until 5. And once you draw the example, you see a pattern. Do you notice the pattern? Where is the pattern actually moving in? Now, you see, for this case, I'm not seeing anything. It's 1. There's 1, 1. Okay, there's another 1, 1. We have a 2 here. Next, we have 2, and then this 2 is being multiplied by 2, which means equal to 4. Now, how I'm actually drawing these patterns is because of the way that they're saying in here. For every nth and kth will be the immediate previous value and this value. Now, what do we mean by that one? For example, if I try to find out what is inside this value, what I would do is simply add these two values. Just the previous one and the previous row's values. Now, I draw the example, and I saw that there's a pattern here. Where is the pattern located? You see, here we have 2, and then we have 2. We can see it's double down, 2 plus 2, 4. Again, it's 2 plus 2 plus 2. Again, 1, 2, and 4. Then 1. So, so far, my pattern is that I'm observing is there will be a 1 on the both ends, and for finding out a particular value, I'm seeing that it's actually, trying to find out the power of 2. Why am I claiming that? Let's take a look at the second example. You see, 1, I could tell it as 2 to the power 0. Then 2 to the power 1, I could say it as 2 to the power 1. Although it's 2, 1 plus 1 becomes 2, but I observed it that it's 2 to the power 1, it's 2 to the power 2. I could also say that as 2 to the power 2. I could also say this 8 as 2 to the power 3. You see that? Similarly, goes to the second row too. So it's actually giving me a power of 2 value for each and every cell. For each and every 2 to the power 0, 2 to the power 0. Also, one important thing is that your input is always going to start the minimum value of n that can be given inside the test case, n equal to 2, and r will always be equal to 1. Minimum value. Not so they won't be. It's important that they are not 1 and 0. Okay, r is not less than 1. R is starting from 1. N is starting from 2, which is important because once you see that, you will start actually from here. Hope I'm right. Yeah. problem. Yeah, there you go. You're actually starting from here. So you'd also notice that we actually don't need the value in here, although we are trying to input here because we are asked to get the input, but we don't actually require. We only need the k value. Oh, sorry to say, the k is actually the r is actually referring to k. So just for the sake of this example, just remember this r is equal to k. Okay, so k's minimum value is 1 and its minimum value is 2. But you would see, or you would notice that each and every row's values are actually playing a same pattern, and you don't even require the value n's contribution in order to find the answer. What do you need? You need the value k, just that. You just need it. What is the value of k? For example, if anyone says, what is the value? If anyone says the k value is 3, now it doesn't matter what the value of n is, because you will get a perfect input that will try to maintain this particular pattern. So for n equal to 3, you're always going to get 2 to the, what is 2 to the power 3 is equal to 8. And where does that 8 lie? It's in here, but I don't actually need to know what is n. Why is that? It's because of this code part. You see that I'm only taking it's because of this code section, this line of code right there. It's actually not putting me any values in here. You see, so the bottom line is that you don't have to worry about the value n. You just have to worry about the value r, and once you get that, you do 2 to the power r. Now the question is, the value can be big. It could be so you need a modulus operation. So what you have to do ultimately is 2 to the power r modulo of whatever the mod number is, and you also have to do it in in efficient form. So the way you can do that is you can apply the logarithmic solutions that you could find out to the power n modulo of number. You could search on the internet. You're just going to get the efficient solution of how to find out 2 to the power n modulo of the mod operation. But I have a solution. You don't have to go that far. I can show you right now, which is in here probably. Okay, it's not in here. I have to take a look at from. Let's see. There you go. There you go. There's the solution. You will take. You see that I didn't care about what the value of n is. I only care about the value k, and that this is the algorithm of finding 2 to the power n in logarithmic time. And also I'm doing this iteratively. I'm not doing any sort of a recursive, providing a recursive solution. It's an iterative one. So yeah, that's pretty much it. I hope you enjoyed this video. Thank you very much.